Yeah. So before we start, lazima to review assignments zenu and your exercise 3 and assignment 1. So I don't have anything to say about exercise 3 because all of you got it right. But on assignment 1, there are some comments that I must make. So let me just select one of your assignments, anyone's assignment. Whose assignment do I use? Let me use Victor's for example. Yeah, Victor, allow me to use yours. Ama ni use ya anonymous. Let me just use anonymous one. Yes, so I'm using the assignment for person X. Yeah, so this person. Wow. So this is a challenge to all of you. Are you seeing what she did? Like, do you see the writings the way they are appearing? She did not use the comment sign. She used another sign called row. So I'll introduce you to row with time. Maybe today before the lesson ends, nitawaambia venye mnafaa kuandika hivi venye this person X did. This was a very good job. Inamaanisha alisoma vitu sikufunza, which is good. So what is Julia programming? Actually, question one, no problem. Question three, not no problem. So I'll talk about question two. I'll talk about question two. Uh, how does Julia programming achieve its speed? By being a compiled language. So there's something I have to say here. There is something I have to say here. There are so many compiled languages. Like C, C is a compiled language. At the high level programming languages also use compilers. So they are compiled languages. Julia is also also uses compilers. So Julia being a compiled language does not mean that that is what makes it achieve its speed. Remember, Julia has a very high speed. The speed of Julia is equal to that one of C. And if you do maybe arithmetic of million numbers, if you calculate, maybe if you want to add million numbers, C++ will do that addition in 10 milliseconds. And yeah, I was saying if you do addition of 1 million numbers, C++ will complete the addition in 10 milliseconds. Uh, Python will do the same in 500 milliseconds. Then Julia will do in 10 milliseconds, just like C++. So that is the speed. Uh, that is how fast Julia is. So how does it achieve that speed? Julia achieves that speed by using a compiler known as just-in-time compiler. There are so many different types of compilers. I don't know the ones that the other languages uses, but the one that Julia uses is called just-in-time. So I was just looking for that word in your answers. So anyone who gave me answers to question 2 without just-in-time anywhere, automatically they didn't get it right. So you must mention that Julia uses just-in-time compiler. And what is the work of just-in-time compiler? Just-in-time compiler compiles and translates all your codes into a computer code before you run them. And I explained that one in lesson 1 and also lesson 0, that if you enter any code, if you enter any code in any other language, be it C++, be it uh, Python or R, if you just write your codes, nothing will happen. After you've pressed, after you've clicked run or you've pressed enter, that is when the code that you've entered will be translated into a language that a computer understands. Then it will be evaluated and you'll get feedback after. But in Julia, it is not translated after pressing run or after pressing shift enter or after pressing enter. It is translated into a machine code before you run it. So what I mean is, if this is Julia, yeah, this is Julia. If you just write 2 plus 2, already it has been translated into a machine language by that just-in-time compiler. So that was the difference before you run. So the moment you run it, yeah, it just gives you the answer. Yeah. Another question. Such a different. Oh, on packages also. There are people who wrote 5 packages, but they maybe got 2 out of 5, because I told you that when you're writing any Julia package, write it using the right format. For example, there's a package called Alpha Zero. You see, Alpha is capital A, Zero is capital Z. So that is how I expected you people to write your functions. And those who wrote their functions with .jl at the end, that was very perfect. That was that was good. It means that it is a Julia package by adding that .jl. Yeah, because there are other packages that they share the same name in Julia and in Python. So if you clarify .jl, it makes it even more defined as Julia package. But those who didn't mention .jl, you are still right, because remember, when you are adding packages using package mode, or using or when using the pkg.add function, there's no way you write .jl, so you are still okay. Write the delimiters. Oh, this is another way, another question we must discuss. I told you people about delimiters. So before I'll jump this question 5, because in our today's lesson I've prepared something on delimiters. So you'll see what delimiters are. Give functions of Julia REPL. Wow, this one I explained. I used a lot of time explaining this. That Julia REPL Julia REPL has 4 main functions, and those 4 main functions are the ones I wanted to see. I said that number one, it reads. It reads. So this is Julia REPL. So if I do 2 plus 3, they have done here, it gives 5. If I do 7 plus plus 6, 4 plus 6 will give 10. So if you enter anything, let's use this 2 plus 3. The Julia REPL will read that code that you have entered, 2 plus 3. After reading it, it will evaluate whatever it has been told to do. It has been told to add 2 and 3. So it will do that evaluation. After it evaluates, it will print out the answer. And you can see the answer is 5. It has printed out 5. After printing out the answer 5, it will continue the process. It will circulate the process. So you see, the process has been continued in the next line. Yeah, you can see the process has been repeated in the second line. It gives you a fresh line to work with. So the next line we worked with 4 plus 6, which is 10. So it read 4 and 6, it evaluated by adding, and it printed out the answer as 10. Then it again gave you another line to work with. So that that process of giving you new lines to work with is what we call loop. So it loops. So those are the four works or functions of Julia REPL: to read, to evaluate, to print, and to loop. So those are the ones I was expecting to see there. Another thing, use string interpolation, display a message that includes the name, age, height, and place of residence of a friend. That was well done. Create vectors of your choice. That was well done. In fact, the answers there was very fine. Yeah, and one of the things that I wanted you people to calculate was mean, but I told you to hold on that mean first because it was not, we tried mean in our last class, but it was not giving us the answer because you need a specific package to work on mean. So to work on those central tendencies, measures of central tendencies like mean, median, and whatever, we need a package called StatsBase. So that's why I told you people to install the package called StatsBase. So all of you, let's open our Julia REPL or the Jupyter. Any can do. Open Jupyter notebook and come to new, create new notebook. Right now, all of you know how to create a notebook. Then after creating a notebook, if you didn't add the package I told you to add, we are going to add it together. After opening the notebook, just write using what are we using? Using PKG. We want to add a package. So using PKG, then in the next line, yes, write pkg dot add. So after writing pkg.add, you string in the name of the package that you want to add. And in this case, you want to add a package known as StatsBase. So just write StatsBase, string StatsBase here. After doing that, then shift enter. So if you haven't added it, it will start adding. But for example, in my Julia REPL, I'd already added it, so it won't add. It will maybe update. Yeah, so you can either add it on Julia REPL or on Jupyter Notebook. So in case you are using Julia REPL, you can follow the same process using PKG, using PKG, then pkg.add. Uh, pkg.add, then string. Remember, all package names are strings, are words, so we must string words. StatsBase. Close the string, close the bracket, then enter. So I believe all of you have added that package in your REPL or in your notebook. After adding the package, now go back to where I told you to evaluate the mean. Go back to where I told you to do some arithmetic operations on mean. So after arithmetic operation, I told you to maybe calculate arithmetic operation on the vector, not mean, the vector. So after that, you see mine have updated on Jupyter Notebook. I believe that on here also in Julia record it has updated. So if you have it already, it will update. If you don't have it, it will add. Now let us calculate mean now using that package. So I'm going to create another vector, any new vector. Uh, yeah, my vector, let's name it x. X equal 1, 2, 3, 4, 5. So that's my vector. In this vector, you can work out anything you want. You can work out sum, you can get the minimum, the maximum, you can sort, and this one is already sorted. So the main thing you want to do here is to wait a minute. Ati nini nini ya charging? Oh, link. Wacha nikutumie. Just mix on. It's good. Oh, yeah, I'm back. So what were we doing? We were working on this vector x. So to do mean or any other measure of central tendency, you use the package that we have just added. So write using start base. Then enter, shift enter, or just enter. You can work all that is in the same shell, or you can work it in a different shell. So you want to work it in a different shell. So just write mean.
Screen.
Oh, sorry. Sir, thank you. Yeah, thank you for the reminder. So I said after adding the start base, write this. We want to use it. So using start base. After writing that, then we calculate the mean of x now. Somebody is requesting to enter to join. Now you see now the mean has been calculated. So that is how you do measures of central tendency, mean, standard deviation, variance, etc. And yeah, that is variance. You see variance is also being given, but you could not calculate variance without the use of that package. So that is another thing. What else? What else do you need to know in the last exercise? I think that's all. The remaining questions were really done well, except that all of you, almost all of you, did question one with ChatGPT. So yeah, actually you can learn Julia using ChatGPT, but or it won't give you right codes. It won't give you all right codes. Some of the codes and some of the statements that you'll get there will be false. For example, ChatGPT was not telling you about just-in-time compiler, but I expected all of you to write just-in-time compiler. So it's good to maybe consult me or consult Julia page. Julia have a lot of content in their page, and their website is julialang.org. Then you can also learn Julia on GitHub. Just create a GitHub code account. Then I'll send you a specific a specific link that you can get you can use to get all the introductory contents in GitHub about Julia. So don't use ChatGPT a lot. It will give you, you won't learn more from it. It will give you some wrong information. Yeah, now let me go to today's lesson. So the way we always do it, we always start by creating a new notebook for every class. So today's lesson, this is lesson 4. So let us create a new notebook and name it Julia lesson 4. Yeah, so that is my notebook. It is nameless. So let's name it Julia lesson 4. Remember, you cannot use a number when naming a notebook. Julia lesson 4. So you write 4 in one. Julia lesson 4. Yeah, that is it. So what do what do you want to learn in this lesson, Julia lesson 4? So in this lesson, we want to learn a little of logical operators, and we want to also see some comparisons. So comparison and logical operators. So let's just start with some common operators that we have learned so far, that we have come across so far. So just create a heading called operators. Create a heading called operators. You know how we create headings. So that's a beautiful one. After creating a heading called operators, we want to look at these operators that we have already come across. So the first operator that you know is the assignment operator. Yeah, or you all know assignment operator, and the assignment operator is this, the equal sign. It's called assignment operator. You don't call it equal sign here. Uh-huh. Yeah, let me use this. Huh? So equal sign assignment. We also have other operators. The next one is the string operators. So when we were learning string, we did what is called concatenation. We also did what is called indexing. And when doing string concatenation, we used the asterisk symbol, the multiplication symbol. So that is one of the Julia operators or on string. It's called a string operator. It is also called a number operator because you can use it arithmetically. We also have the one that the power one. You see, this is a power symbol or index symbol. Remember, power is also known as index. So, for example, 2 power 2. So this is the symbol for it. You can do power operation on string and on numbers. When we learn about functions, generic functions, you'll see how we use the power symbol to work on strings. Then we also had number operators. We also had number operators. And number operators, these are the ones you have seen since class 1, since nursery school. We have subtraction, we have addition, we have multiplication, and in programming, that is the one we use. We have division sign, that is what we use. Um, we also have what else do we have in arithmetic? We also have this power one. So these are number operators. These are number operators. Then we have type operator, and this one we are going to use in today's class of functions. Type operator, you are going to see it when we reach there. So delimiters. I told you I gave this one in last yesterday's assignment, and I said delimiters are used for different data type use different delimiters. For example, to write a string, you must use these uh, the double quotation marks. So the double quotation marks are the delimiters for strings. Then to write a character, you must use the single quotation marks. That is its delimiter. To write arrays, you use uh, the, 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 the square bracket symbol. Or when doing indexing, you also use the square bracket symbol. For function arguments, you use these brackets, the round brackets. The round brackets are also used for tuples. We didn't learn tuples but we were to learn it in our last class, but we didn't learn it. So you will see tuple. You use this one. It is also used to specify the order of arithmetic operations. So let me just express all of these delimiters and how they are used. So number one, we start with we start with strings. We learned strings. We learned strings. So to express a string, you use that delimiter, the double quotation mark. So maybe you want to write your name, you must write it inside that double quotation marks. So you are called, maybe your name is Anthony. That is how you write strings. Then we have vectors, for example. I say in the I've said arrays instead of vectors because there are so many types of arrays. Vector is just one type of an array. We have vector arrays, we have matrix arrays. So taking vector as an array, for example, if you want to write any vector, let's say you want to record the age of the students in a class and store them as a vector. You use those square brackets as a delimiter. So you input all the ages inside there. So 22, maybe 23, 20, 21, and that is how we express vector. And you can see in the output, it is also indicated that it is a 4-element vector and all are integers. Then, so the same with indexing. For example, to index this vector that you have just created, you just write age and index. Let's say you want the first person, the age of the first person in that stored data. You just enter 1, then it will give you the age of the first person as 22. And if you confirm in the vector, it is indeed 22. I also said that if you want the last person, you can write. We have 4 people. You can write 4. It will give you 21, which is true. But let's say if you have so many numbers and you don't know uh, which one is the last one, you just write end, then it will give you the same output as 21. So that is a delimiter that can be used in indexing as well. So we have this one, round brackets. Round brackets you can use in writing any function. For example, all our functions, we've been writing them using the round brackets since we started. Even right now, added, we have just added a package using pkg.add as a function. We wrote pkg.add, then the round brackets, and everything was written inside the round brackets. We added stats base. So that is how we express a function, and we use the round brackets as a delimiter. So I believe now you know how to differentiate a delimiter and those other operators. We also sometimes we consider this the you see an error message because we didn't command it to use pkg.add. So sometimes we can consider this comma as a delimiter, but it is not associated to any specific. It's not associated to a specific data type. It is just used in so many other data types. For example, in vectors, you separate the values using comma. So that one can be called a separation delimiter. Now, on the next one, we want to look at some other operators. The ones that I've just mentioned are the ones that we usually use. Since the beginning of our lessons, we've been using them, but these ones are the ones that we have not yet encountered, and we want to encounter them today. Yeah? So logical operators. Now, logic has two constants. In logic, we have only two constants, and that is true and false. So if you hear anything logic, just know we'll be talking about these two things, true and false. So there are so many operators that we use in logic, and one of them is this exclamation mark. So I'm going to tell you what it means. So before you go to exclamation marks and the and symbol and these two straight line symbols, the parallel line symbols, we are going to use to see the comparison operators, which also work with logic. And these ones you learned them in high school and in primary school, so you are familiar with them. The first one is greater than symbol. Greater than symbol, and that is how it is written. So you can insert any values. Let's insert any value, one from the left and another one to the right. So left, let's write for example 21, then greater than 12. If you press shift enter, what will it say? It will say true, because it is indeed true that 21 is greater than 12. What if you say 12 is greater than 21? It will tell you false. So these comparison operators and logic operators, they work together. What about 12 is greater than 12? It will also say false because there is no greater number there. The next one, we have less than. We have the less than symbol, and just try writing 10 less than 11 or 12. It will tell you true. Then 10 less than 30. It will say false. Another one that we have here is greater than or equal to. We also have for equality. Remember, I told you that the equal sign is an assignment operator, but we have two equal signs which are not assignment operators but are equality operators. So let me demonstrate what they do. Where were we? Yes. So we have two equal signs. These are called equality operators. It will tell you whether one number is equal to the other, or one statement is equal to the other. So for example, if I write 10, it will tell you true. So this means 10 is equal to 10. So what if I write 10 to tell you false because it is not true? So these are some of the operators that we have in logic and comparison. We have greater than or equal to, less than or equal to. So the logic constants that I was talking about are here, true or false, as you can see them. Now, after knowing these comparison operators and the logical constants, let us go back to the exclamation operator and the and operator and the parallel operator. So let us start with the exclamation one. So this exclamation symbol, when you use it with logic, it means the opposite of the truth. For example, if you write true and why is it not responding? Mm, hmm. Yeah, for example, let me just use this example. For example, we know very well that 10, we know very well that 10 is greater than 5, for example. We know very well that why is it marking down? Yeah, we know very well that 10 is greater than 5. So if you shift enter, it will tell you true. But if you use the exclamation, the operator which has the exclamation symbol, it will tell you false. Have you seen that? It will tell you false because this is an operator that says the opposite of the truth. So it is true that 10 is greater than 5. But now when you use the operator, it tells you false. So it is called not. That is why it is called not. You see its name? Not operator. Then we have and operator, we have or operator. We are going to see them when tackling sana when tackling user-defined functions. Yeah, on generic functions, I want us to do generic functions. After generic functions, we do some little stuff on visualization. Then in the next class, we shall do user-defined functions. Functions is too large. We cannot finish functions. So we will do them in bits. So starting with generic functions, these are functions declared with one or more generic types. So I'll tell you what I mean by one or more. So we are starting with one. And when I was telling you about operator, there's this operator called type operator. You see it here, the one that I have highlighted, the one that is highlighted in I've highlighted in yellow. That is a type operator, and we use this type operator on generic functions. So it is used to create these generic functions, and I'm going to tell you how to create them. So to create generic functions, we use that symbol, of course. Then we declare everything that we want to operate. So, for example, in this example one, we want to double. double values of x. Let's say we have a variable called x, and this x has a lot of numbers. For example, it may be height, age, anything, distance, and we want to double each and every element of that x. Instead of just writing all and uh, putting them times 2, we can just have a common function that will automatically do that work for you. So that is what a generic function is. It is a function that is declared with one or more generic types. So the ones that we want to do, we want we want to declare them with one type only. The one that is declared with more types, you should do in an advanced Julia class. So let's start. Let's say, for example, we want to double numbers and start with that example one. Remember, I told you about data types. So data types will also be applied here. So we want to double. So let's write double. You can write anything. So in this case, let us just write double, and then we use the round brackets. The round brackets are our delimiter here. So double, let's say x is what we want to double, and x can take any value. Then after writing x, use this symbol called type symbol, the type operator. Now, when you want to double things, if you want to work with whole numbers, you must declare inside here that you want to work with integers. So write integers, int 64, because we are working with 64 bits. If yours is 32, you can write there int 32. But if you write int 64, it will still work. So that one I won't change anything. Then after writing that, just go outside the bracket and equal sign. So this equal sign is what is this is where you tell this is where you declare what you mean by doubling. So to double is to multiply by 2. All of you know that. So just write 2x. Remember, it is x that you are working with. So to double x, we write 2x, right? So if x takes any value, let's say x is 10, double it is 10 times 2. That is why we are using 2x, all right? So shift enter. If you press shift enter, it will tell you what you're working with. That it is a double. You want to double, that is what you want to do. I told you that double that I've written, it can be anything. You can write anything there. If you want to write sort, if you want to write maybe x, y, you can write it anything. But remember to use it when you are working out your when you are solving. Uh-huh. Yes. Just a minute. Sasa kwa hiyo simu yake, enda nunua GB ya 1 hour hizo za 20 bob, 1 GB for 1 hour. Hii yangu iko karibu kuisha. Simu 1. Oh, unacheza game? Yeah, nunua before hii class itoke. Yeah, so let's continue. Huo msesi nimembaia credo hapo sahi bwana. Ama ni simu tu? Hebu angalia simu tu. Amewasha ya simu 1? Kwani ashatumia zote? Hebu angalia balance na uangalie na expire saa ngapi. Sahi ime expire bana. You lost your network connection. Oh, imerudi 7:45. Oh, kumbe ni kama ashanunua tena. Oh, so I lost my connection but I'm back. So you see what is written here, double is a genetic function with one method. And the method is to double, double now. That is the method. So it is a genetic function with one method. And we are working with integers. So after declaring like that, if there is any integer that you now want to work on, you just enter it there. You just write yeah. So what we declared is double. We want to double things. So just write double. Then inside the bracket, you input any number that you want to double now. For example, let's say it's 675 that you want to double, will give you that. Maybe you want to double another one, double. I told you that when you press tab, it will autocomplete anything that you want to write. So you see, we don't have to write everything times two because we have generated a function that will help us double anything that we want to double. And it can only double integers. That's why we declared int64 there. So what if you say double something that is not an integer? For example, a float. If you double a float 8.8.6, for example, it won't give you anything. And this is why I told you when I was teaching you about the numbers, that number type is very important in the error messages, because if you don't understand number types, you cannot uh, ex, uh, you cannot know what the error message means. For example, in this error message, the first line reads, no method matching double float. And inside that bracket, you've been told float 64, meaning ours, which is int64, cannot be used to work anything that is a float. Closest candidates are double int64. So it is telling you everything that it is interpreting to you the error, and it is giving you a suggestion on what you could have done. So if you don't understand number types, you won't understand the error messages. Most of them, they'll be given in number types. So what if we want to operate floats? The same process applies. The difference will only be when declaring, you don't declare int, you declare float. So let us do that as an example. So our float, let's just name it Y or Z, or maybe F, yeah, to just symbolize float. F, then inside the bracket, we want to declare our variable, which is Y, and we declare it as a float. So here you write float 64. Nanani? Hello? Oh, poa. Niko class, unipigie after some time. In the next 30 minutes. Nipigie after 30, sawa? Haya. Yeah, so I was declaring a float. So you write float 64. Mm. Oh, why not defined? It is not defined because we are not yet done with our stuff here. So it's equal to, let's say, what do we want to do with with our float? Let's say we want to get powers. We want to raise to power 2. So y y raised to power 2. Yeah, we want to square in short. So it will tell you that f is a generic function with one method. Now, enter whatever you want to square. For example, f, and enter maybe 9. No matching. Oh, so you see, I'm also confusing floats and integers. So we've said we want to declare floats. So floats are decimal numbers. So f is 9.45, for example, it will give you the answer. Y f is maybe what? 2.0, will give you the answers 4.0. So that is how you generate a function to work on different things. You can generate a function to work on integers, on floats, then on strings also. Others can work on strings. So let's create one for strings. So let's call it str. Str, and let's say our string is z. Then z is a string. And what do we want to do with that string? Let's say we want to double the string. In doubling numbers, we multiply them by 2. But in doubling strings, which are words or any other, we don't use the multiplication sign. We use the power sign. So let's say our string z, we want to double it. We use that symbol. This is a generic function with one method. Now let us double our string now. Str, and a string must be written using the string delimiters, which are the double quotation marks. So anything to write inside here, for example, your name, you can write your name there. So my name, for example, Mackenzie. So if you do that, it will write Mackenzie Mackenzie. So it has doubled the name, the word Mackenzie, right? So that is how we can we can use generic functions with strings. I believe you're also trying the same on your side, on your side. So that is a generic functions. Those are generic functions. When we are learning functions, the next function we shall be learning will be user-defined functions. And user-defined functions, we shall use a lot of logic. A lot of logics will be used there. So it will be combined. So after this, let us look at something on visualization. Let's look at something on visualization. So you can just write a title, visualization, heading. I believe when you are following, you saw how I used the raw format. Heading for now we know how to use heading format, code format. Markdown is just a format that will continue looping another shell down. So let's look at visualization. So imagine you are a statistician, you are doing statistics, or you are doing a mathematic course. Some of you are not imagining because those are the things you are doing. But if you are not doing those things, you can imagine. And if you are doing them, you can also imagine that you have a data to work on, you have a data to manipulate and work on. Maybe you have calculated so many things like the mean, the variance, the standard deviation, and all that. Then you want to present this data to somebody who have never, to people who have never entered a statistics class like you or a mathematics class like you. Do you think they'll understand anything like you tell them the standard deviation is 5.5? Maybe it is a standard deviation of the GDP per capita in a country, of a data that was collected to calculate GDP per capita in a country. They won't understand it. Or just a simple example, you have different age values. You want to say that the standard deviation for the age in this class is 20 or 20. Can a standard deviation for age be 20 in a class? That is so ambiguous. Let's say 5 or 3. Do you think somebody who has never stepped into a statistics class or a mathematics class will understand that, or variance, or mean, even mode, even median? They won't understand easily. But if you give them a visualization of whatever you are talking about, if you tell them that in this data, this is how the data looks like, they'll see in the visualization, and they'll just conclude that hey, hawa ni wengi, hawa ni wachache, like that. So that is what we want to see here. We want to create some visualization that you can use to present different types of data. And because we are just introducing visualization, we want to do one visualization. We want to visualize histogram. So I could have told you people to type for me any values there in the comment section, but that one is going to take a lot of time. So let me just cook values. Let me just cook values. Age. I'm used to age. I don't know why. Every time I think of age as a variable. So let's say age of people in a room are as follows. 21, we have 22, we have 20, we have another 21, we have another 21, 21 wako wengi hapa. We have 23, we have another 23, these were born in the year 2000. We have 25, 24, lazima upate last born, maybe 18, 19 must also be there, 19. This may be a second year's class. I don't know whether a 25-year-old can be found in a second year's class, but maybe, yes, they are there. We have another 23. There's an age that must dominate. 23. Most of them must be born in the year 2000, actually. 21 again, 20, 21, 23, 24. Then kuna mzee fulani alidifaa for 2 years akarudi 27. So we've presented our data as a vector. So let's say you want to create a histogram for this data. What do we do? Number one, when we were starting using Julia, there's a package I told you all to add, and the package was called plots. So that is what we want to use here, assuming all of you have it. If you don't have it, you will just add it at the end of the lesson, because you cannot add it right now and use it right now. It will use like 7 minutes to install. So using plots, after saying using plots, then you can create a histogram now by using the word histogram. Now, what histogram do we want to create? We want to create a histogram for age. So just write age there and wait for the histogram to plot. Oh, it's taking time, but let's give it more time. Yeah, it is here. So you see our histogram. So if you present this one to any person who have never attended any statistics class, at least they will interpret something. They'll visualize something. For example, below age 20, as you can see, we have three people. So three is between two and four is three. So that is below age 20, 20 and below. We have three people. And if you go to our vector, which has the data on age, and count all those people below 20, you'll find out that there are three, 20 and below. So the first one is 18, 1, 19, 19. So below 20, we have three people. Or it's not 20 and below, it is below 20. Then uh, below 22.5 up to 20, we have seven people. You see this bar, it is up to seven people. So many people are between 20 and 22. So you see how I'm interpreting it. Yeah, many people are between 20 and 22. If you tell somebody like that, you don't need to explain further because you'll just see that indeed the frequency of those between 20 and 22 is high. It is 7. Then below 22 and 25, it is reducing, and then the 20, only one person has 27. So between 27.5 and 25.0, we have one person. So you see how we interpret a histogram like that. So if you tell somebody that way, he will understand easily. He will understand easily, right? But what do you notice with our histogram? Our histogram has no title. Our histogram has no the X. Uh, we've not labeled X. We've not labeled Y. So it is just there. So we want to do some manipulation. We want to decorate our histogram a little bit by adding those things. So just go there where you wrote age, inside that bracket, put a comma, then add a title to the histogram. You add a title by just writing title, then you string the title. Title is a word, so you string it. So what is the title of our histogram? Let's say, for example, uh, age. So we've named it the histogram for age values in a class, right? So that is the title of the histogram. You can see the title has been added there beautifully. We can also add, we can label the X and the Y. So to label X, just write X label. Maybe X label contain frequencies. So you can write frequency. Then, oh no, it is Y that has frequency. So this should be Y. Yeah, it's Y now. You can see. Then what is X? X is age. X contain age. Let's say age limit. Age limit. Age age limit. Uh, Label. I've not written label well. Now you can see age limit. What about you want if you want to change the color of the histogram? What if you want to change the color? To change the color, just add color, color, and string any color that you want to use. Maybe we want to use gray. Yeah, beautiful. It is now gray. You can use any color that you can imagine of. Red, and it will give you a red one. My favorite color is black. Yeah, it will give you a black one. What's another color? Um, Let me write white and see how white will look like here. I will. Oh, white will just be like this. Huh? It looks like a normal drawing. Also beautiful. You can use pink. Yeah, pink looks smart. Huh? So that is how we visualize histograms. So if you present this data to anyone, they will now understand when you are trying to explain to them that many people from this class are the age values of many people from this class ranges between 20 and 22. Somebody will understand, right? Yeah. But if you tell them that the mode of the age values of this for people in this class is 21, will you really understand the mode? What mode is we want? But if you tell them that the mode is the most frequent, using using histogram, which uh, graphs age against frequency, you will really understand by seeing. So that is the work of visualization. Make it easy because somebody is seeing whatever you are telling them. Now, there is this command that you can always use to generate any number. So let's say you want to generate, there's something I want to explain with histogram. this histogram that I've created. So before I elaborate it, let us use let me uh, uh, elaborate something here. You can generate some random numbers. Let's say we want to generate, let's say the variable is n. So you want to create a variable n which will consist of some random numbers, and random numbers, maybe 100 random numbers. So if you press enter, you will get some elements. In this case, it has created some vector elements which are all floats. So in the with these numbers, if you create a histogram with these numbers, let's say you want to create a histogram of those numbers n, histogram for those numbers n, you will see something like this. Let me create another histogram, random numbers. Let me just use one command to create a histogram now. Histogram. So we want to create a histogram. A histogram of what? Of random numbers. How many random numbers? 1,000 random numbers. And again, we close the bracket. You see the histogram? Now, there is something I want to explain with these three histograms that I've created. The first one I created out of the data from my just random data from my head. Then the next one I generated random numbers, 100 random numbers, and created this one. The last one I generated 1,000 random numbers and created this one. So what I want to explain here is the shape of these histograms. Do you see the shape of this one? Just look at this one. Have you seen it? Then look at this one. Have you seen it? Then now look at mine. Have you seen it? So there is something that is common in the shapes of these three histograms. It is common. Number one, what is common is that there are a lot of values in the middle. A lot of values fall in the middle. As you can see here, a lot of values are here. So let's say these were some thermometer temperatures recorded. You find out that a lot of values are ranging between -2 and 2. I don't know whose temperature uh, the, tem the temperature of which substance is that, but it is ranging between -2 and 2. A lot of it. In the middle, come to this one. A lot of information is found between -1 and 1. Come to this other one. A lot of information is found between 20.0 and 25.0, which is the middle. So what this means is that these are random, these are normal, these are normal distribution. A normal distribution, I want to explain to you what a normal distribution is from just maybe from examination that you always do. If you people do examinations out of 100, let's say it is a class of 25 students, and you do an examination that is marked out of 100. In that examination, you will find out that let's say for example those who fail, uh, wenye wamefail sana kwa hizo examination, maybe amepata out of 100, mwenye amefail anaweza pata nini, let's say it's mathematics 20%. So somebody has 20%, another person amefail akona 30, another person amefail akona 40, It is a class of 25. No, no, 40 hajafail. So maybe another one akona 21, 22. Then watu wengi, you'll realize, and it is normal, that most people will be somewhere in the middle of 100. Most people will fall under 50, 51, 57, 60, 70. So 60 to 70 will have a lot of people. Let's just say 40 to 60 will have a lot of people. Then above 60 watakuwa sasa excellent students, machopi. Machopi wa Daro watapata above 60. Na machopi wa Daro wakwangi wengi. In a class of 25, you may find out that we have how many chopis? We have maybe 7. So 7 chopis wako na maybe wawili wako na 65, mmoja ako na 65, mwingine 70. Watatu hivi wako na 80 something, then mmoja ako na 90. 6 chopis Then come to wenye wamefail. Wenye wamefail, one has 20, two has 30s, another one has 35. So how many people are those? We have, let's say, 5 failed ones, 7 machopi. That is 12. It is a class of 25. The remaining people will fall between 40s and 60s, 45, 57, 60. So that's a normal distribution. All right. So if you just generate numbers, random numbers, if you just generate random numbers and create a histogram, the histogram must be normal. The histogram must follow a normal distribution, meaning less data to the right, less data to the left, and more data centrally. Right? So I think you've learned something in statistics. If you are not a statistics student, you've at least learned something. You can brag about that one in your village. Yeah, if you see any graph or in any periodic table, even in an hospital, just tell them this is not normal. This is normal. So, ladies and gentlemen, exercise for today's class. We are done with today's class. So I'm going to give you an exercise, and our exercise will consist of 2 questions. The first question is on generic functions, and the second question is on the visualization that you've just done. So let me just create for you one out of nowhere, out of what we've done here. On generic functions, create a generic function that will double numbers. That is number one. Number two, that is number 1A. Number 1B, a generic function that will double strings. Number 1B. Now number 2. So a generic function that will double number, you can use any. If you want to use floats, use floats. If you want to use integers, use integers. If you want to use all of them, even better. You can use integers. After that, go to floats. Accepted. Then the last exercise, then you can leave. The last exercise, create a histogram of your type, or any histogram. Create any histogram. Actually, just create any histogram using any values. Any values, you can get values from anywhere and use it to create a histogram. You can just estimate values, maybe height, things like that, distances, Maybe your friends, your 10 friends, you ask them the distance between their home and school, and use that information to create a histogram and etc. So those are the exercises for today's class. And I'll by the end of this week, you'll receive your nini. You'll receive your one project that you should work on. Then after the project, I'll send you the results. The results will just come once. The results that is consisted of the exercises that you've done, the assignments, and the and the what and the project that I'll give. So that one is on Thursday. Actually, tunataka tumalize on Thursday. This week we won't have a class on Friday unless otherwise. But I want us to do today was Tuesday, then tomorrow's class, and then we finish on Thursday. So you can change that one in your schedule. So in the next class, we are going to do continue with functions, if else loops, if else, and then some user defined functions, and then we go back to visualization. That is tomorrow. Then Thursday, again, visualization. So we want to do visualization a lot. So that is the end of today's lesson, and you can leave. Thank you for attending.